This video will discuss the basics of the computer DNS service. DNS stands for Domain Name System and is used to help human and computers work together. The first thing to remember is that computers are not intelligent the way humans are. Computers understand numbers very well, but have a hard time understanding human language. What DNS does is provide a list of names that human can relate to and equates each to a number or series of numbers that computers can relate to. This is often used to indicate a website. In the following discussion, I'll show how I've set up DNS service in my own home network so I can access websites in my home. I have not shared any of my websites outside of my home, so this is purely educational. So here we're looking at slide 1. Computers communicate to each other using something known as an IP address. That's an Internet Protocol address. My desktop is 192.168.1.55. They communicate through network switches. So on the other side of my switch, I have a DNS server at 192.168.1.200, and then I have an infra server that has my website at 192.168.1.145. So what happens is my laptop, if I ask it to go look up a website, specifically parksmap.pierce.home, it has no idea where that is. So what it must do is go ask a server that does, which is what the DNS server does for it. So my OS has to know, my operating system has to know what servers can answer its questions for what human names want, what a human wants. So we have a file called resolve.conf. So this is my resolve.conf, and as you can see, my name server is my DNS server. I also have a line called search.pierce.home. What that does is it adds pierce.home to the end of any host name that I type. That lets me just type the host names and not have to do the whole type. Let me give an example. So nslookup dns.pierce.home. Alright, so I gave what's known as the fully qualified domain name. Said pierce.home. Since my DNS is told it is the master of pierce.home, basically it answered that question of who dns.pierce.home is. If I just do an nslookup on DNS, what it will do is, because of this search path has pierce.home, it automatically added it for me. Alright, so I've been told, 1, where my DNS server is, and 2, if my human uses shorthand, I'm going to add pierce.home. Now let's go take a look at the DNS server. So I'm going to use the shorthand, and it behind the scenes converted it to pierce.home, actually asked the DNS server where that is, and then SSH to that IP address. So let's take a look at the primary configuration for DNS. Actually, okay, so there are a lot of things in here to go over, and a lot of it's getting kind of complicated. However, what we're really interested in when we come down is this zone area where I've configured a zone. What a zone is basically telling the DNS server that when you see pierce.home, you're in charge of it. That's the reason it's been told it's a master. And it's been told, here is the configuration file that answers all the questions for pierce.home. Notice I have a second zone. This zone is for IP address. If I know the IP address, I need to know the host name that's associated with it, it will go look in this file. So let's go look at these files. So we're looking in var named D, that's the default location, and let's look at the forward file. If you recall, the forward is the file that's set for when you're given a human name, what's the IP. So here it is basically being told that it is the primary file for this particular domain, and here are all the names and numbers. So there's the DNS's record. Here is all the other ones, and notice here is the infra one that I pointed out earlier. We're going to be looking at him in a minute. Now, of particular interest is the star. I wanted the ability to be able to type anything .pierce.home and have it convert it to the infra IP address. So this is a wildcard. What happens is if you do ns lookup a name .pierce.home, it will look through this list to see if it matches anything, and if it doesn't, then it will drop to here. It will find this infra line, and it will drop back in the top and go find this infra line. So it will convert it to this IP address. So let's see this in action. So if I do ns lookup, say r900.pierce.home, whoops, you'll see that it came up with this line 100. In fact, if you recall, since I have this thing set to automatically add pierce.home, I could have just said r900. Remember, that's in my local resolve.conf for in my search, right? It's my search. Okay, so now let's look for something that, let's look for the infra. Look up infra 1. So there's infra 1. Now let's look for something that is not in the list. Okay, so what it did is it said, I know you're looking for arg.pierce.home. Guess I'm being a pirate today. And it gave me something called canonical name. Essentially it's saying, hey, the real name for this is actually this infra1.pierce.home, and here's its IP address. So that's how that wildcard works. Alright, so let's go take a look at the reverse. The reverse is essentially all the same information but with the IP. And why they reverse the actual order of the numbers is something I never fathomed, but that is the way it works. So if we do an ns lookup 168.1.130, it will go find the line and said, hey, that one's associated with pierce.home. Okay, so the upshot of all this is if we bring up a browser and we type in parksmap.pierce.home, what this will be doing is it will, under the covers, be doing an ns lookup it will go through the file and it will not find ParksMap. It will hit the wildcard. It will come back up with infra substituted, find the infra, and then it will go to that IP address. So let's see how that works. enter. And there's my website that is being hosted on my Infobox. Thank you for now.